Okay, so that half sheet of paper is going to be used to answer 3 questions before we leave here today. All right. The stuff that we're looking at today is not necessarily stuff that's in your book, but it's kind of stuff that is expected of you at this point. Okay, so I'm going to show you those 3 questions now. All right. I don't want you to write them down, but I want you to ask yourself, do you know the answers to any of these 3 things? Okay, when it says to write that in standard form. We've heard standard form before. Okay, standard form of a linear, don't write them down. Standard form of a linear function had to be in the form ax plus by was equal to c. You remember that? Okay, but that looks a little different than this does here. Okay, to identify a degree of a monomial. Any idea what that means? Okay, where are you pulling 1 from? Okay, so a prefix mono meaning 1. So the question would be 1 what? Okay, 1 number. All right. And then lastly, to classify the polynomial. Well, prefix poly meaning not necessarily 5, but more than 1. Many what? Well, maybe. I don't know that 5x squared looks like a number to me. Does it look like a number to you? It does. You look like you're on a merry-go-round or something right now. I don't know what you're doing. Okay. So these are the things that we're going to get into today. Not a lot of math per se, but some terminology of things that we kind of need moving forward. All right. So this section, I mean, you can title it Polynomials. This is the beginning of chapter 8. Almost in my notes, I titled this as section 8.0, kind of like a introductory piece. We'll officially get into the first section on Tuesday when we return. Okay. So that half sheet of paper, you can keep it out. You're going to need it here in just a couple minutes. All right. Before we get into that today, though, maybe just a little bit for the brain. Probably don't need a calculator to do any of these 3. Hopefully, maybe. Can you give me an answer to one of those 3 questions? I don't care the order. Mia?
Number 1.
Okay.
Is 7.
Is 7. All right. Okay. Number 2 or number 3? Richard?
Number 2 is 13.
Number 2 is 13. Very good. Any takers on number 3? What do you think it is? 2. Very good. Okay. When it says to evaluate, you must have a value to plug in. We're not solving, okay? So in each of these situations, I was simply taking that value and plugging it in to find the result that I was after. So in this case, a result of 7. Okay. Number 2 could have produced a different answer had you used a calculator. So thank you to whoever gave me a number. Who was number 2? Was that you, Richard? Number 2? Yeah. Well, what could have screwed you up in number 2 had you used a calculator? Yeah, if you grab a calculator and type in -3 squared, what are you going to get for an answer if you don't use parentheses? You're going to get -9, and -9 plus 4 more might want to produce an answer of -5. But remember, if I'm squaring a negative number, I really need to think about it like that. And that would say 9 plus 4, and that's where that 13 came from. Okay. How about these? Can you answer any of those? If you know what a coefficient is, shouldn't be a big deal. If you don't remember what a coefficient is, it's a little bit more tricky. What do you got?
4.
What?
The first one.
Second one is?
0.
Not 0.
Oh,
A 1. And the last one is?
2.
2. What is a coefficient in words, Alexis? What would you call it? Absolutely. It's a number in front of a variable. Okay, so that is a coefficient. So today, as we get into these kind of ideas, it's kind of like this here. If I know what it means when I'm talking about the word coefficient, it's not a big deal. Just simply whatever that number is in front of the variable. But if I don't know what that means, well, then I'm just kind of looking at a wall. All right, I don't really have any clue what the heck I'm going on. So Can I classify a polynomial? Well, before we get into classifying them, we're actually going to have to define what a polynomial is, okay? And so we'll get into that, and we'll get into this idea of how do you put it in standard form. Not hard, all right? And if we have time, we'll get into this evaluating of a polynomial. But if not, no big deal, because we'll definitely hit it next week for sure, okay? So definition-wise, a monomial versus a polynomial. Well, Richard immediately pointed out that the mono prefix meant what? One. So the question really was one what? Well, could be one number, all right, or it could be one letter or variable, or it could be a product of those two things together. Okay, so it could be a number, 5, could be a variable, x, or it could be the product, the multiplication of those two ideas together. It is not allowed to include division. Okay. So if you see over here in the not monomial kind of idea, negative exponents will produce the idea of division because you got to write it as the reciprocal. You got to think about the moving it from the numerator to the denominator. That division takes place. It's no longer a monomial. Now, this one right here in the middle, well, it doesn't have division. It's got a letter, and it's got a letter and a number together, which are all things that are true of a monomial. Why does this one not work? Take a guess. Well, this one has a negative. Look over here. It's a good try though, right? Like something in there is different. They are subtracting it. Okay. If you look down here at the bottom, it says a polynomial is essentially monomials that have a sum or a difference in them. A sum or a difference. This is actually two monomials put together. We use a different prefix when we have two of them put together. If we were in science class, I bet you'd want to use the prefix die for two. Yes? But all you non-drivers out there, you probably still have to use one of these right now, and it uses a different prefix at the beginning of it. A what? A bicycle. You ain't got no driver's license. You got to ride that bike. Okay? And the prefix bi simply means two, so this would be called a binomial. As a little kid, you use this three-wheeled bike, a tricycle. So when you have three things put together, we call it a trinomial. Okay? If we have more than three, then that's when we use the prefix poly and we say polynomial. Okay? So if we just have one term or one part, so maybe it looks something like this, 5xy squared. That is a number, a letter, or the product of those two together. That's still just one. That's a monomial. The moment I add in an addition or a subtraction sign and I put a second term down, no matter what it is, as long as it's a number, a letter, or the product of them together, that now means I have two of them all together. So maybe this one says, 3x. This went from being a monomial to now it has two things. Now it's a binomial. Okay? As long as I don't bring in addition or subtraction and I continue to multiply, so, let's say, I don't know, y to the fourth, z squared, I don't know. That's still a term on its own, so it's still a binomial. As soon as I bring in another addition or subtraction sign, it's now about to become a what? Trinomial. So today isn't really mathematically driven, it's more in that terminology piece. So when I hear the word trinomial, I should be looking for three parts. When I hear the word binomial, I should be looking for two parts. When I hear the word monomial, I should be looking for one. Just like at the beginning when we used the word coefficient, you were looking for a number that was in front of a variable. Okay, so this could be anything out here. I don't know. Whatever. Could be a number, it could be a letter, or it could be the product of those two together. So as I look at these two down here at the bottom, what's the first one? It is a binomial. And then the second one, Braden, what is it? Who? I don't know.
My bad. I said trinomial.
I mean, she gave you the answer and you stood in
I
here.
didn't mean to.
All right. What's that?
I go to sleep.
You don't know? What's the matter? Oh, okay. So this first one here, with just one operation sign, addition or subtraction in between it there, we get two parts. So we get a binomial. Here we see the two signs, so that separates it into three parts. We call it a trinomial. Okay. Now, one other thing we're going to get into today is this idea of classification. And so I would call this one over here, this first part, I would call it a seventh degree binomial. Why do you think seventh degree?
It's more severe.
It's more severe. Okay. I just randomly chose the number 7. Yeah. What's that? Because the exponent. In the second one over there, I'd call that one a fourth degree.
The biggest one is like the
Uh-huh. Absolutely. That the one, whichever one of those terms has the highest amount of exponents in it, essentially, is what's known as its degree. Okay. Now, if I change this, what's the power on this z right here? Its power is a 1 right now. If I put a 3 on it, this would no longer be a fourth degree. You want to take a guess on what it would be now? Not 7.
Still 4.
No.
second degree.
You showed me the right answer, but you said the wrong answer. It'd be a 5. How would it be a 5?
Because it's the number in between.
Number in between what?
3 and 4? Yeah, that's fine.
Oh, I thought it was the 7 and 3.
Oh, I get you. Over here, this one, in this second one, in B over here, this one would be a 5.
If you look closely, it says 1.
Any idea why?
4 then 5.
Because this one here, this term at the beginning, has a w squared and it has a z to the third. And so together, those two would give that degree a 5. Uh-huh. Now, I'm not changing it to a 5, okay? But its degree, what it has the most of, it has 5 in that one. If I came to this one here, that's a trinomial. What's its highest degree, though? It's not 6. You're close. You're looking in the right place. What is it? No, not second. I thought
7.
it's 7 because the x has a 1. And this one here in the middle has a 2, a 4, and a 1. So its degree would be considered a 7th degree because that's how much it has in it total. This first one only has how much in it? It has 3. It's got 2 here. This one has, that x has a 1 on it, so it's got 3 in it total. What's this last one have? None. It doesn't have a variable. So which one wins? The first term, which has 3 in it, the second term, which has 7 in it, or the last one, which has none in it? The one that wins is the one in the middle. It has 7, so it's a degree of 7. Okay. A lot of people get the words degree and power. They almost kind of use them interchangeably, but that's not true. These are individual powers, but its degree is what it has altogether. Okay. So when we start to look at degrees, though, then we start to talk about this thing called standard form. And standard form isn't anything crazy. All right. But every answer that you submit from this point until you're done taking a math class, whenever that is, maybe that's when you're a senior. Maybe that's when you graduate from college. Okay. Maybe that's when you finish your master's. I don't know. Anybody plan on going that far? You thinking that far down the road? Okay. Every answer yesterday on your map test that had more than one variable and a power in it was in standard form. You didn't know it at that point, but it was. Standard form says we rank them in order from their highest degree to their smallest degree. So right now, this polynomial that has 4 parts in it is not in the correct order. Which one truly should be written first? Not the 9. That's the highest coefficient. The highest degree. Which one has the highest degree? Okay, the 7x to the 5th. Now that 7x to the 5th has a negative in front of it. So in fact, that one is, you gotta tag that negative in there with it. Okay, this one would be written first. Which one should be written second? In order from the greatest to the least. Which one? It's 4x squared. This one should be second. Which one should be third? Jayla, which one? The 6x. What's the power on that 6x? A 1. Right? So this one should be written third. And then obviously, which one goes last? Okay, the 9. A number that does not have a variable next to it is called a what? A constant. Constants are always going to go last because their degree, okay, is ranked by their variable, and they don't have a variable, so their degree is a 0. They're last. Okay. Well, actually, if you want to get technical, you're like, no. If this one has an x to the 5th and an x to the 2nd and an x to the 1st, this one really could be written like this. What happens when you raise something to the 0 power? It's equal to 1. And if you did 9 times 1, what are you getting? Still getting 9. So it doesn't affect its outcome. He just likes to be that guy. Okay. It's kind of his thing. All right. See? Okay. So that really could go on the end of there if you wanted to. Now, the last piece, and this isn't, you can kind of pull this, I think, from its definition. When you write something in standard form, the coefficient that's in the front of the first term, that's called the leading coefficient. You don't have a leading coefficient until you put it in standard form. Okay. So if I was going to write this negative 7x to the 5th first, what would be the leading coefficient? What would be the leading coefficient? Mia, think you know?
-7.
Negative 7. Okay. So in your notes, I want you to put one of these two down. I don't care which one you do. That's the same problem, so we don't need to use it. I want you to put one of those two down. Write it down. And then next to it, do it like this. So let's, I don't know which one you're going to put, but if you're going to do this one here, put an arrow above it, write standard form, and then over here, what does it look like if I put it in standard form? Okay. Remember, standard form says you're going to put them in order according to their degree from the highest to the lowest. So whether you decide to do the first one or the second one, whatever, the majority of you will pick the first one because it only has 3 parts instead of 4 parts, right? Hey, thank you. That was Maddie Metzger choosing to do the more difficult one. That's a shout out right there. Okay. So thank you, Evan.
I do it because I can.
Richard's a show off.
2 plus 2 is 5.
That's right. In Richard's world, 2 plus 2 is 5. All right. So if you chose the first one, what's the order that they should go in? Mia, what do you got?
I did y6 first,
Y to the 6th.
then y to the 2nd.
So what would go, so you're going to write y to the 2nd, but there's got to be something there.
Plus.
Why is it a plus?
Because the first number is positive, and so y to
Okay.
And then -3y.
And then
Subtract those
-3y. This has 1, 2, 3 parts in it. So I would call it a what? A trinomial. 3 parts. And its degree? 6. So I would call it a 6th degree trinomial. Okay. All right. What about the second one? Now it has 4 parts. Of the 4, which one goes first? Kylie, what do you think? Okay. X to the 5th. What goes next, Sam? After this x to the 5th, of the remaining 3, which one goes next? Okay. And the symbol that would go in between these two? Okay. Dylan, after that, which one goes? Good. And obviously at that point, then the 16 would be last. Okay. This has 4 parts. So I would call it a what? A polynomial. And its degree? 5. So I would call it a 5th degree polynomial. Okay. Now, when we get into the idea of classification, there are a handful that we give specific names to. So we had just said a 5th degree, but in fact, a 5th degree has a name, quintic. Could you imagine like having quintuplets, 5 babies at the same time? Huh, I have. I can't even begin to imagine having multiple babies at the same time.
Did you see her stomach when she was
Yeah, trying to. But there's 8 of them in there. Like, where do you think they're gonna go? Like, there's only so much room. The only option is like out or this way or up. I don't know. There ain't nowhere to go. You got stuff in there that can't. It's got to stay. Okay, that's crazy. All right, that's great. Thank you. So when we talk about that degree, all right, that's where then these names start to come in. So for example, I'll bet you yesterday on your map test, there were a bunch of you that got quadratics on your test. Now, it might not have used the word quadratic. Did anybody have the word parabola on their test? Parabola. Anybody get a picture of like a U-shaped graph that looked like that? Okay, so that is an example of a parabola or what is known by name as a quadratic. Okay, I'm about done with your statements today. Okay, yes? Sure, draw it and you can add 2 circles inside of it. It could go upside down. Yep. Now, if I saw this graphed, it may look something like that, give or take. All right. Did anybody have a question on their test yesterday that asked them for more than one value of x? So like x equals and had a blank and then another x equals and it wanted more than one answer? Did you have something like that? All right. That happens, and we'll get into this, but that happens because of this picture. This picture crosses the x-axis 2 times, and so therefore produces 2 answers. Okay, that is by no coincidence in line with the fact that its degree is also a 2. All right. Up to this point, we've only ever dealt with things that had how many answers? 1. And their name? Linear. And their power was a 1. Like, think about something that could be graphed as a straight line. Y equals 2x minus 5. The value of that x, the degree of that x, was a 1. If you thought about graphing it, where does that cross the x-axis, or in how many places would a straight line cross the x-axis? Just once. And if it only crosses once, it only produces 1 answer. By the time you guys get into Algebra 2, you'll move into this next degree known as a cubic. And because its highest power is a 3, it can potentially have how many answers? 3. And graphically speaking, cubics will look like this. They will do something that kind of looks like that. Okay, because they cross 1, 2, 3 different times. So that degree matches that picture that ultimately matches how many answers you can have. All right. Now, I'm not asking you to understand all of that at this point, but I need you to realize that that's how these things are tied together. Okay. These functions that, like here, if you had a constant, it has a degree of 0, because if you graph just a number without a variable, you get a horizontal line. You ever done that on Desmos by mistake, didn't realize that you didn't have that variable in there, and you're like, why is my line just going straight across? Well, when it goes straight across, it never crosses the x-axis. And when it doesn't cross the x-axis, guess what? There's no answer because there's no variable, because there's no power, there's no degree. It's all missing. All right. And so we start to kind of tie these ideas then together. But we, for about the next 6 weeks, are going to live in this degree of 2, this quadratic looking picture. And whether it's facing like a smile, or Maddie, like you said, upside down, kind of like a frown, it's still going to produce. I mean, if I took that graph and I flipped it, it still would potentially produce 2 answers, in that same fashion. Okay. Yes, sir. It cannot. That's a good question. So Sam's saying, can my graph, if I'm hearing you, Sam, you're saying, can it go this way? Like if I turned it like that? Okay. The reason here, if you remember, and this is way back, it would fail what's known as the vertical line test, where it crosses that vertical line in more than one place. Okay. But if I take that picture and I rotate it this way, does it pass the vertical line test? It does. Or like Maddie was saying, if it faced that direction, does it pass the vertical line test? And it still does. So it still is a function that still then can produce, because it crosses twice, still can produce 2 answers, but it cannot face sideways. Those are good questions. All right. So last thing we're going to get into before we use your half sheet of paper, there are 6 expressions here. Here's what I'd like you to do. I want you to pick one. I want you to tell us which one you pick, but I want you to name it. And if you name it correctly, the rest of us should be able to figure out which one you're talking about. In order to name it, we must first do it by its degree, and secondly, by its terms. Okay? So, for example, let's say this was our problem. I would call this, in red, a cubic binomial. Cubic because its highest degree is 3, binomial because it has 2 parts. Okay? So I don't want you to tell us which one you're looking at, but I would like you to pick one, and let's see if somebody else in here can figure out which one you're speaking of. Evan, you want to give it a shot?
Oh, no, I was raising my hand because earlier your email stuff was showing on screen for a moment.
My email was?
Yeah, I have a small little window on the bottom.
Oh, could you read it?
Not much, but if you were confused, you could enhance it and read it.
Oh. All right. Well, there ain't nothing there to worry about, but thank you, though, for that. What do you think, Sam?
8th degree trinomial.
An 8th degree trinomial. Which one is Sam speaking of? If you hear 8th degree and you hear trinomial, Richard, you know what he's talking about? The bottom one. Very good. Highest degree there is an 8. There's 3 parts. So an 8th degree trinomial. Very good. You got one?
Yeah,
A constant monomial. The 6. Very good. Okay. You got one, Mia?
Would it be cubic degree or cubic?
Well, to call a degree of 3, you would call it a cubic. But then secondly, by its terms, a monomial, a binomial, a trinomial.
Okay, I was just asking about the first part.
Oh,
Would it
okay.
be cubic polynomial?
Nomial?
Nomial?
Nomial. Yeah,
Sorry.
that's okay.
The
The
fourth one.
4th one down. Good. Cubic by highest power of 3, 4 parts. Cubic polynomial. Dylan?
6th degree polynomial.
6th degree polynomial is which one, Kylie? The second one. Very good. Okay. So we got 2 left. You name either one of those. Holly, can you name one of those? cubic binomial? She's talking about the first one. We only have one left. Braden, can you name it? A linear monomial. Very good. Okay, a linear. What's up?
Are they just saying those words what the first degree
Oh, yes. So anything from a degree of 0 to 5, we have a name for. After that point, we just use whatever the degree is. So you wouldn't be wrong to say third degree, but you most commonly would hear it as cubic. Does that make sense? So in those first 5, I think because they're probably the most common, we use them. Yes, sir. You have cubic burns, like a third degree burn. I like your transition over there. All right. Now, that half sheet of paper that I asked you about at the beginning, here are those same 3 questions, and I'd ask you, can you tell me what's the first one look like in standard form, now that I know what standard form is? Secondly, what's the degree of the monomial in the second one? And in the third one, to classify the polynomial should come in 2 ways, by its degree, and then lastly by its term. So you should have 2 names for the third one.